In this lecture, we will talk about the internal energy of a system. I am Dr. Imran Ali. So let's start this lecture. So, objective of this lecture is that at the end of this lecture, students will be able to understand the concept of internal energy. So, in this lecture, we will discuss first about the macroscopic forms of energy, then we will discuss microscopic forms of energy, and then law of conservation of energy. And then, based on these instructions, we will understand the concept of internal energy. And at the end of the lecture, I will deliver a summary of the internal energy and okay. Now let's start. Microscope. First of all, what are the microscopic forms of energy? Let's suppose you have a ball and you are standing at a height edge. So what kind of energy this ball have? Maybe that is called potential energy. I think you all have studied this in your FSC and metric classes. That this is not something new. I think. Um, so this ball have some energy and we call it potential energy. So the energy due to the position of an object in a force field is called potential energy. Okay. Mm, let's suppose and when you are in that force field is a gravitational force field when you are standing on earth, so that energy is called gravitational potential energy. So if you have a mass at height h, and then this potential energy will be equal to mgh. Okay, now let's suppose you have dropped this ball. Okay, and this ball starts moving, so its potential energy is converted into kinetic energy. Okay, so what is kinetic energy? The energy of an object because of its motion. So as the ball is moving, the energy it has is called its kinetic energy. Okay, how we can calculate the kinetic energy? You all are the familiar with this formula 1 by 2 mv square. Okay, so from this, we have observed that both the potential and kinetic energy are associated with the body as a whole. Okay, so both kinetic and potential energy are described of this whole ball. Okay, this ball. Okay, or this system. They are associated as a whole with this ball. Not we can say this part, this, that, or the molecules or the items like this one. So these forms of energy are called the macroscopic forms of energy, those forms of energy that a system possesses as a whole with respect to some outside reference, such as kinetic energy and potential energy. It means these energies are associated as a whole with the body. We consider that this energy of this ball or this energy is of this ball. Okay, so and they are also measured with respect to some reference frame, like maybe you can say if you are on earth, we will measure with respect to the earth frame of reference. Okay, I think this is all you have already studied in your BSc classes, sorry, in metric and high school classes. So these are called the macroscopic forms of. Now let's take another example here. As you have some glass of water. Does a glass of water have some energy? Any guess? It is not moving, no motion, so no kinetic energy. At the ground level, so no potential energy. So on your apparent observation, this glass of water have no energy. No apparent and this glass of water have basically no energy, no kinetic energy, so it do not have any macroscopic form energy. But remember that every object that is below zero above 0 Kelvin have some energy. Okay, so but if you see on the microscopic level or the atomic scale, these particles are also moving, so these have some kinetic energy and there are also some interaction forces between these molecules. Okay, so they have also some there are also attractive forces between them, so they have also some potential energy and they have also some kinetic energy. So how you will consider this energy? Okay, so for this we have defined another type of, and so these kind of all these energies, those related to the molecular structure of a system and the degree of molecular activity, molecular structure or the molecular activity, and they are independent of the outside reference. These are called the microscopic forms of energy. So this glass of water is independent to the outside reference frame. Either your glass of water is here or it's here or it is here, its microscopic energy is same. Okay, so they are independent. Either your glass of water is here or placed here, its microscopic forms of energy they are same. Okay, so we have studied about the macroscopic and the microscopic forms of energies. Okay, law, what is law of conservation of energy? You have all studies, I think also you have about this one. The law of conservation of energy, energy can never be created or not destroyed. It also, in other words, you may say that the total energy entering the system minus total energy leaving the system is equal to change in the total energy of the system. So E in minus E out is equal to change in energy of the system. Now let's implement this law of conservation of energy on some examples. If you are applying some force F on this spring, what will happen? If you apply law of conservation, that energy go, it's increasing its elastic potential energy. So we have seen also in the last slide an example that where when you drop this weight, its potential energy is being converted into kinetic energy. Okay, and in let's take another example. If you are charging an battery, then its electrical energy is being converted into its dielectric energy. Okay, so in all these examples you are applying law of conservation of energy, and you are also familiar with this. These are the just common life examples. Let's suppose you have some gas and you have a pedal and you are rotating this pedal and doing some work W here. Okay, so according to the first law of conservation of energy, E in minus E out is equal to delta E. So this whole box did not move anywhere. So no motion, no kinetic energy changing. It's still remained on the ground level. So no change in potential energy. So where this energy go? Work is also an energy. Where this energy go? Now let's think. I think. So, in order to define, to measure that energy, the scientists have developed the concept of internal energy. So, as we maybe it have increased its temperature or added some heat at the microscopic level, as we have studied in the second slide that about the microscopic forms of energy. So that is basically called internal energy. Invisible microscopic energy associated with the random disordered motion of the molecules is called internal energy. So this work have increased this internal energy. Okay, so some maybe you can also say the sum of all the microscopic forms of energy of a system is called internal energy. Maybe like you can say in this example, this glass of water has some in all the energy. This glass of water, this is called also called internal energy, microscopic forms of energy. Okay. So an internal energy is denoted by U. The change in internal energy is equal to U2 minus 1, U2 minus U1. The specific internal energy is symbolized by U. Okay. So how we can measure the internal energy? Internal energy of a system is equal to mCV delta T. Okay, where CV is the specific heat is That is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. So what is CV? CV is the specific heat, and that is equal to amount of heat required per unit mass to raise the temperature by 1 degree centigrade. Okay, so that is equal to delta U is equal to mCV delta T. So mm, now let's relate internal energy with the first law of thermodynamics. Or it simply you may say that what is the implementation of internal energy? Let's suppose you are heating some water in a pan. Heat is going into the system, but it's not moving like I have explained in your previous example also. So where that energy is going, there is no work done. So and before heating, this molecular activity was small, and after heating, its molecular activity have increased. It means its internal average energy of the molecules have increased. That is called temperature, or simply you may say U is equal to mc v delta T. Yeah, and it means internal energy have increased. Here is energy U1, and here its internal energy is U2. Okay, so that is basically also um, called first law of thermodynamics, where the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. In this example, there was no work done. Okay, there was no work done. So all the heat added is used to increase its internal energy. Like you have some, but in this example, if you supply some heat q, it will do some work, plus it will increase its internal energy of the system. Okay, so that was the concept of internal energy. Now let's summarize this, that microscopic form energy those a system possesses as a whole with respect to some outside reference are called the macroscopic forms of energy, and microscopic forms of energy related to the molecular structure of a system and the degree of molecular activity. Okay, and the sum of all the microscopic forms of energy is called the internal energy, and it is denoted by U. So thank you. If you have any question, you can ask.